Hello, I'll be doing a presentation about atoms, bonds, and structures. When metals and non-metals bond, it is called ionic bonding. This is when there's a transfer of electrons. When they are loose, this becomes positively charged ions, and non-metals, when they gain them, become negatively charged ions. They are held together by the strong electronic forces in it. An example of ionic bonding is sodium chloride. Non-metal bonding is called covalent bonding. Non-metal atoms do this. Electrons are shared within the atoms and they achieve a stable electron configuration. This creates a strong bond between them. An example of this is H2O. Metals bonding is called metallic bonding. The atoms form latitude of positive ions, and the outer electrons, which is called a C, delocalize electrons. These are more freely movable for to move around the structure. You will find this in magnesium. Electron negativity is when an atom attracts shared electrons in a chemical bond. This will attract either atomic size, the nuclear charge, electron configuration. There are 3 chemical bonds based on electron negativity. One of them is ionic bonds. There's a large difference between these, and one atom, the metal, loses electron, which becomes negative. The electronic opposite ions are held together by this. The more larger they are, the more ionic bonds it is. You'll find this in sodium chloride. Covalent bonds is another one. This is when the electron negatives are similar. The atoms share electrons and they become stable electron configuration. Non-metals and non-metals do this, and it's called non-polar covalent bonds. The difference is minimal, and they share equal electrons. You'll find this in H2O. Polar covalent bonds is a moderate difference. Electrons are shared unevenly. The particles are both positive and negative charge. Polar molecule cause a permanent dipole moment. The greater the electron negativity difference, the more polar bond there is. The bond between hydrogen and oxygen in water is an example of this. Physical properties of substances. Some of the physical properties of substances are melting point, boiling point, solubility, conductivity, hardness, and color. In simple covalent, there is a discrete molecules held by covalent bonds. They have low melting and boiling points. They are gases, liquids, or solids, or soft solids at room temperature. They have weak intermolecular forces between molecules. London dispersion forces, dipole interaction, and hydrogen bondings, these are called. The weak force allows the molecule to move easily around. Another one is giant covalent. Lots of the covalent bonds throughout the structure. This has a high melting and boiling point. Diamonds, graphite, and silicon dioxide is some of the examples of this. The structure is strong. Covalent bonds in 3 dimensions, and it makes a network. in its hard and insoluble. Another one is ionic. This is a positively charged and its metal ions and negative non-metals held together by electrostatic forces. It has a high melting and boiling point. It takes a lot of energy to break the bonds as it is strong and it is soluble in water. Metallic is, for example, copper and iron. This descalized electrons surround positive charged metal ions. Electrons allow easy moving and high electric conductivity. This makes the metals luster, malleable, and ductile. Electron pair repulsion theory is when electrons pairs orbit central atoms and they stay away from the sphere shape. The shape of a molecule or Platonic ion can be predicted by this theory. Some of these elements, the way to predict the shape, some of these shapes that can be predicted is linear, trigonal, planar, trigonal, bipyramidal, and octahedral. Linear has 2 electron groups and 0 lone pairs. Trigonal planar has 3 electron groups and 0 lone pairs. Trigonal bipyramidal has 4 electron groups and 1 lone pairs. Octahedral has 6 electron groups and 0 lone pairs. The ion shape and molecule shape are different because molecules are neutral, whereas ions have a positive or negative charge to them. Molecules are held together by the covalent bond. Ions by electronic forces. Ions' charge include adding things to it, considering the shape. Having to consider the shape prediction, it becomes a bit more difficult. Storing elements in compounds, you have to be careful and they are stored differently. For example, solids have a definite shape and volume, which means it needs to be protected from moisture, air, and other contaminations, whereas liquids have a volume but not a defined shape, and this will mean it needs a sealed pressure and a resisted container. In gases have neither a defined shape or volume and also would need a sealed pressure or resistant container. It also helps knowing what it is, whether it's a solid, liquid, and gas before storing it. It helps to keep the element or compound safe when you are handling it, and you know then how to handle it for testing. The forces between ions and molecules are ionic bonds, covalent bonds, hydrogen bonds, diplo-diplo interactions, and London dispersion forces. The stronger the force, the higher the melting and boiling point are. This requires cool, dry, and stable environment for it to fully be okay to use and test. Thank you for listening to my presentation, and I hope this helps you in the future.